Hey, what's up everybody? Noah from Adafruit. Welcome back to another tutorial. Today we're going to make some custom threads to make a twisty top. So if you've seen like a regular type of spray bottle and a lot of other type of bottles, you see that they have these custom threads here. So those are actually pretty easy to make in Autodesk Fusion 360. This is sort of something I made a little bit ago, which uses a coil feature in Fusion 360 to make this custom thread. So you've probably seen me use the standard thread feature in Fusion 360, which makes standardized threads. So this is a good tutorial on how to make custom threads for something like this, or if you wanted to make something like a twisty top for a bottle. So let's go ahead and take a look at the CAD. This is mainly for objects that are cylinders. So I'm just going to draw one out right now. Let's say it's 46 millimeters. And the tallness can be whatever it is. It's arbitrary, maybe 30, like that. Hit OK. So if you try to apply a thread to this guy, let's click on that. You'll see that it sets the size to 45, even though that we want it to be 46. Let's say it has to be 46. So using a thread, you really are constrained to profiles, specific thread profiles. So like this is using the metric profile. But if you were to use like unified screw thread from INSI, you're kind of locked into those threads, and you can't like tell it exactly how you want. So let's hit cancel on that, and instead you can use this coil feature. So the coil kind of makes a coil, right? But you can use this to make a thread. So I'll show you how to do that now. So I'll draw on this bottom plane here, and I'll just click in the center and type in 46. Like that, and by default you'll see it's a little bit weird, but we can adjust it accordingly. So the first thing I would say is to change the operation from cut to new body, because we want to make it a new body. And the second thing is to change the section size, and the section size is the size of the section of the coil. So I like to use 4 millimeters, which seems to be pretty good. And the next thing is the height. You could type it in, but if you use this arrow here, you can just kind of manipulate it a little bit easier. So this is arbitrary. It's up to you, however you want. However tall your cylinder is, you can modify it to that. And you can see that it's kind of going off the bed a little bit. So we can cut that, or we can move it up a little bit. It's up to you depending on your design. But I think that's about all we need to do. The diameter is set to 46, which is the same as our cylinder here. So that's going to equal about the same amount. So that's all good. And then if you look at section, you can see you have different types of shapes. So by default, you're probably going to see the circular one, but the one that works the best that I've found is the triangular external one, which gives you that triangle look at it. And because it's a triangle, it's at a 45-degree angle, so you're actually looking pretty good when you 3D print it. You don't need any support material. Again, this is for 3D printing. Probably didn't mention that, but it's all good. So I'll hit OK. We're looking, actually I'll make the size a little bit smaller, like 24, just so I have a little bit of room to move it up. So I'll hit OK. Now what I'll do is I'll grab this. Since I made it a new body, I can move it around freely. And oops, let me click on the object first, and then click the move tool. So it's a little bit easier. And then I can move it up like that. So now it's more or less in the center. So I'll hit OK. And now normally what you would have is like a shell throughout this little cylinder. So let's go ahead and add a shell. I'll make it all the way through by shift selecting it, both edges here. I'll just put like 1.5 or something, which looks OK. So you'll see that I have a little bit of excess here. So to remove that excess, I will actually use this surface of this cylinder to cut this away. So to do that, I'll use the split body command. So I'll hit split body, which is under modify. And I'll click on the threading, and then I'll use my splitting tool. Will be this surface here of the cylinder. So I'll click on that, and I'll set. I want to keep the tool. So instead of using split body, let's use combine, because combine kind of does the same thing. So I'll click on this one first. And then tool bodies will be this guy here, and I'll hit keep tools. And you can do either way, but I think this will work. So now what I've done is cut it out. I think I cut it out. No, I combined it. Oops. Let me double click on it and change that to cut. And bring that back and then hit OK. Alright, so now you'll see that I have this inner part here, which I can remove. Not delete, but I'll just hit remove. Always want to hit remove. And now I'm free to sort of combine this. So I'll do that in a second here. So one thing I want to do is I need to make the cap. So let's make the cap next. So I'll just make another cylinder, draw it again on this floor plane. And it needs to be a little bit bigger than the cylinder and the thread. So I'll make it about 52. We can modify that and change it a little bit differently later on. And I'll make this a new body. It needs to be a little bit taller as well. So maybe like 2 millimeters taller or so. And I'll hit OK. And then I need to make a shell here, right? So I'll click on that and then make a shell, probably 1.5 as well. And you can see I have a pretty big difference here. So at this point I can kind of change up the diameter, maybe make it 50 instead. And now it's a little bit closer to that. And you can see my threads kind of poking through a little bit. And if we add I definitely recommend adding a section analysis. So I'll click on section analysis and turn on my origins, and then click on one of these guys, and you'll see, I'll hit OK here to confirm the section analysis. I can cut through and see that, yeah, my cap needs to be bigger because you can see that triangle is like cutting through that material. So that's not good. So let's make it, maybe I should have left it at 52, right? So I'll hit OK. But my shell needs to be a little bit less, or it needs to be a little bit more. So I'll make the shell a little bit thicker here, maybe 2 millimeters, 2.5 maybe. So you really got to play with it. So I think 2.5 will work out really well. And you'll see that I have a little bit of a clearance here, a little bit of a, that's good. So that's a 0.5 millimeter right there. My face is kind of covering it. But let me move my face real quick. All right, I have successfully moved my face. There we go. So you'll see here at the bottom corner it says minimum distance is 15.50 millimeters. That's 0.5 millimeter. So I think that's pretty good. And the next thing I'll do is I'll turn off section analysis for now. And this is our inner bottle area. So I'll hide that, just revealing this here. So the next I could do is I could actually do another subtraction. So I'll subtract my cap as the target, and I'll subtract this coil from that, and then I'll say cut, but I want to keep the tools because we need to keep that, that coil. So I'll hit OK, and you see I have the coil still, and now I have this cutout here. So let me turn on the section analysis again just by turning on that little light bulb, and you'll see that it is a nice cut across the entire cylinder. So one thing I need to do is I actually need to add an offset to these two faces here, to these two edges, or yeah, face surfaces rather. And you can use the press and pull feature. So I will click on one section and then change the offset type to new offset, and then hold down shift and then click that second. And you'll see it goes around the whole thing since it's one surface, one continuous surface. It'll go around the whole thing. So I'll actually add a negative value about 0.2. So you can see that effect changing. If I hold down my command key, you can see that's what the new one is, and that's before it. So it adds a little bit of a tolerance, and this is really good, important rather, for 3D printing. So if I bring back my coil, you can see that there is a little bit of a gap there, and that's perfect. That's what we need. We need that gap. Otherwise, it'll be way too tight when we print it, because material tends to expand when you print objects. So now at this point, I'm going to turn off section analysis, and I'll hide my cap here just to reveal this, and I'll actually merge these two. To do that, I'll just use combine, and just combine these two, the coil. Obviously, the operation needs to be join, so I'll change that to join and hit OK. So now I got that. Another thing I want to do is you'll see here that this surface here is like straight on. And a good thing, if you notice on your like spray bottle, those custom threads have a sort of a chamfer to them. So I can select these two lines and just add a chamfer. And I noticed that sometimes even though I know it's supposed to be 2, it won't do 2, so I end up doing like 0.1.999. So you can see that. It adds a little bit weird extra line there, which is strange, but it's all right. It should be fine when you print it. So now it's like looking like that, and I can add a chamfer as well to the inside bottle, the inside cap part. Let me see. Why do I have 3 objects? I see. I kept that tool there, so we don't need this tool, and that's why it's still there. So you can remove that because we only need those 2. There you go. Now that line has disappeared. That's what it was. All right, noted. So this is our inner bottle area, and then this is our cap. So in the cap, you can see we can add a chamfer to this area here, to this line. So I'll add a chamfer, and you'll see that it's given out an error on me. So I'll just put like 1.89, and you can see that's pretty much the full extent of it. And then I'll hold down Command to select that area as well, and then it'll add a chamfer there. So I'll hit OK. So that's pretty much our cap area, and this is our bottle area. And to see through it, again, we can use section analysis. You can see that there's a you can see here that it kind of won't work here, so I need to make this taller. So I can go back here in my timeline. Y'all can see the timeline. This one here. This needs to be taller, so maybe like that much, I think. There you go. Now there's a lot of air room. So you can obviously play with that and get it nice and tight, however you want. So yeah, if another way to see it better is probably to apply a see-through. There's a new version I haven't updated yet, but there's a way to like add transparencies to objects. So what I'll do is I'll just add a glass material by right-clicking anywhere and then saying physical materials, bring up this window, and I'll drop a glass material so I can see right through there. So that gives you a better idea of how it looks like. So I think that looks pretty good. And it works out really well. Here's my CAD of the little spiral top that I was showing you, the little twisty top. And in my case, I found that I ended up pretty much placing that coil all the way to the floor of this area here, or at least this surface here. It like kind of cuts into it. You might need to do that. You might not need to do that. It kind of depends on your design. But you can see here that the top didn't matter so much because it just cuts right into it. So it's pretty much the same thing. So one cool thing about it is it's very adjustable. It's very flexible, right? So if I go back here to the coil, let's say I want to add 3 revolutions. So I have to like kind of add more rotations to it. So I'll hit OK, and then everything just follows through that. So again, parametric timeline is super amazing, and it's very flexible in that sense. And you could probably modify other features, like maybe the thickness or the section size of it. But I found that 4 millimeters works pretty well. And printing at about 150 microns is a little bit better too. So that's about it. This is a great way to make a custom thread if you want to make a twisty bottle top. So you're not so constrained to the specific threads profiles that are in the thread tool. So the coil can be used pretty cleverly as a way to make custom threads. Of course, you do want to add that bit of tolerance because I have tested it where there was 0 tolerance and it just doesn't work out. So you really do need to add that offset right here, that little offset that I made. It's pretty easy to do. But there you go, guys. Let me know if you make any projects with it. I'd love to share about it and take a look at what you guys made. But that's about it for this one. Thank you guys so much for watching. I'll see you in another one. And be sure to subscribe to us on YouTube, and be sure to check back with the playlist for more tutorials on Fusion 360. I'm Noah for Adafruit, and I'll see you guys later. Bye.